Hello and welcome to the next video lesson in the series. Today we're going to look at 4.4 Venn diagrams and conditional probability. Now Venn diagrams is something that you've seen in the past, and that's where you have essentially two overlapping circles. And sometimes you'll have more than two overlapping circles, but this is what a Venn diagram looks like. Okay. There are three ways you can identify or draw a Venn diagram. Okay. One is using percents. So for instance, if you have 15% for event A, and for event B you have 20%, and maybe the overlap is 5%. So really you have a total of 20% for A and then 25% for B. Now with percents, you're going to want to make sure that all the numbers add to 100% because you want to take into account everything. So if I have 20, that makes 40, so that means I have 60% that's not accounted for. I'm going to put that number that's in neither A nor B into the bottom right-hand corner. So it is helpful to draw a little box around it so you can organize it in one little space. Another way you can do Venn diagrams is with probabilities. Okay. So probabilities. And that's going to be all numbers between 0 and 1, including those numbers. So 0.15, maybe 0.05, 0.2. Those are very similar to the numbers I just had in the first example. So those are going to be for events A and event B. And we still have a remaining 60%, so 0.6. If you use probabilities in the Venn diagrams, you have to make sure that they add to 1. Which is equivalent to 100%, because again, you want to make sure you account for everything. The last type of Venn diagram could just be using just number of things. Okay. So let's say I have event A and event B, and we will look at just number of things. Okay. In number of things, they must add to the total. Okay, they must add to the total. You must again account for everything. So for instance, maybe there are 5 people who share A and B. Maybe there's 17 people who only are in event A but not in B. Maybe there's 12 people who are in event B but not in event A. Okay. Notice that totals up to 34, so let's say we have 50 people. If there's 50 people and there's 34 in all the circles, that must mean that there's 16 remaining. Because 34 plus 16 makes 50. Or another way to think about this, 50 minus the 34 gives you the 16. Okay, so you have to account for everything. So in that bottom corner, is going to be the number of things or number of people or elements that are not within the circles. Okay, so that's just a little bit of review of Venn diagrams. So we're going to start off with some very basic examples before we get to something called conditional probability. So, number 1. Notice in this problem we're dealing with percents. Okay. So let's go ahead and draw in our Venn diagram. Draw in our two circles. For now, we're just going to be dealing with Venn diagrams for 2 circles. They could be the same size, different size. One looks a little larger, but that's okay. Now, you have to identify what the 2 circles are going to be labeled as. Okay, so we have 40% of a group are male, and 30% watch the History Channel, while 20% are males who watch the History Channel. Create a Venn diagram to find the following probabilities. So it looks like we have 2 things. We have male, and we have Watch History Channel. Now notice with these Venn diagrams, you're going to have the complement of these things are going to be the opposite. So anything that's not in the circle for male, anything that's outside of there must be females. Anything inside the circle for Watch This History Channel is going to be History Channel, but anything outside is going to be those who don't watch the History Channel. Okay. So let's fill this out. first thing you want to do is look for the intersection. And I see that 20% are males who watch the History Channel. So males and watch History Channel is going to be 20%. So I'm going to put 20 in the middle. Now I'm dealing with percents. I don't have to write the percent symbol in there, but I just know I'm dealing with percents, so just keep that in mind. Now once you fill out the intersection of those two circles, now you have to fill out the remaining parts of each circle. So if 40% of the group are male, then that means the remaining in that male circle must be 20%, because 20 and 20 make 40. And 30% watch the History Channel, so the remaining in the History Channel must be 10. Now you have to ask yourself, does that account for 100% of the people? And no, it does not. 20 and 20 and 10 is 50%. So you have to take away 50 from 100% to give you the remaining 50% is in neither one of those circles. Okay. So now let's look at this Venn diagram. These next few examples are going to really hint at and show you how these Venn diagrams can be interpreted. So if it says, find the probability of being female. Well, that one's a pretty easy one. We know 40% are male. Okay, so the probability is 60%, or in other words, 0.6 in probability sense, because probability is always a decimal. But 60% are going to be female because 40% are male. And if you look at the Venn diagram, where does that occur? Anywhere that's not inside the male circle, so there and there. 10 and 50 make 60. Now the question for part B says, find the probability of females who watch the History Channel. So we just saw that this 10, this 50 are all the places where you have females in the diagrams. Now where of those do they watch History Channel? Well, the 10%. So 0.1 is the probability that you have a female who watches the History Channel. Part C, find the probability of females who do not watch the History Channel. Well, that must be the complement, so that's going to be the 50%, or in other words, 0.5. Okay. So let's just recap this problem just to clarify what all those numbers represent. Okay, this 20 represents all the males who don't watch the History Channel. This 20% represents the males who do watch the History Channel. This 10% represents the females who watch the History Channel. And then this 50% out here is going to be all the females who do not watch the History Channel. Okay, so each of those numbers represents a specific thing. Copy down anything you need to before moving on. Okay, now let's get to something called conditional probability. Conditional probability is going to be the probability that an event happens given that another event happens. Gotta love the stylus pen. Okay. The probability that an event happens given that another event happens. So you're going to have two events. And what this really means is you're going to have two circles. So if I say, for instance, find the probability of A given B, and this is the way you're going to notate it, is A vertical line B. Okay, that means A given B. And we have probabilities A and B, events A and B, sorry. Events A and B. What we're doing, since we're given B, we're just looking at only the numbers within event B. Now, where in there do you have event A? Well, right here, right, where they intersect. So there's a formula for the probability of A given B, and then is going to be the intersection, probability of the intersection of A and B divided by the probability of event B. You're just taking the intersection of both events, because that's where A occurs in the same time that it occurs with B, dividing by the probability of B. Okay. Now, it goes without saying as well that you could also have the probability of B given A, and as you might be able to guess, it's the probability of A intersected with B divided by this time the probability of A. Okay. Same formula, but this is the first way is the way it's usually seen. Alright, so let's look at number 1. Now in this case, notice the probabilities of event A and B are given as probabilities, not as percents. Okay. So let's draw our Venn diagram. Label A and B. Now it says the probability of A is 0.6, the probability of B is 0.5, and the probability of their intersection is 0.2. So again, fill out their intersection point first. So 0.2 goes in the middle. And that'll help you fill out the rest of the Venn diagram. So if A is 0.6, that means you have to have a 0.4 remaining in the rest of A. And if B is 0.5, then you must have 0.3 remaining in B. Now we're dealing with probabilities. You have to ask yourself, do they all add up to 1? So let's check this. 0.4, 0.2, 0.3. Well, that adds up to 0.9. So that means I have to have a 0.1 remaining in neither one of the circles. Okay, so each of these are going to be conditional probabilities, except for that last one. And I'll talk about that when we get there. So find the probability of A given B. So you want to look to see where their intersections are. In this case, it's 0.2. And you can divide by the total of B. So the entire thing is 0.5. 0.2 divided by 0.5 is 0.4. So the probability of A given B is 0.4. Probability of B given A, so the intersection point, is going to be 0.2 divided by the probability of A, which is 0.6, and that gives you 0.333 repeating. So the probability of B given A is 0.3 repeating. Okay, and that's conditional probability. Now for this last example, probability of A union B. Okay, so when you see this symbol, that means the word OR. Just like the intersection symbol that we have up above, right here, that means AND. Both have to be true for the intersection. The upside down U, right side up U is OR. Okay, so it's just going to be A or B. It means anything that occurs in A, B, and in both. Okay, so in this case, 0.4 plus 0.2 plus 0.3 occurs in all A and B, and that accounts for everything in those, so it's going to be 0.9. So the probability of A or B is going to be 0.9. Okay, pause the video now and write down anything you need to before moving on. Alright, now let's go to sum up this lesson. Okay, so we looked at Venn diagrams, and there's 3 different ways you can set up a Venn diagram: with percents, with probabilities, and with numbers. Okay. Now there were no examples in today's notes where you have numbers of things, but rest assured you will see some. Okay, and one thing to also remember with Venn diagrams is that you have to account for everything. Meaning that if you're dealing with percents, they must add to 100%, probabilities must add to 1, and numbers must add to the total. Okay. And the other thing we looked at was conditional probability, which is probability of A given B is going to be the probability of their intersection A and B, divided by whatever you're doing the probability that you're given of, okay, what you're out of. Okay, what that really means is that you have two events A and B. You're looking at the intersection out of what you're given. Okay, you're just given B. Okay. The rest of the problem is irrelevant. All right, thank you for watching, and see you in class.